Today I will share with you a lecture on trigonometric Fourier series. After this session, you will be able to find the trigonometric Fourier series. There are three types of Fourier series. The first one is the exponential Fourier series, second is trigonometric Fourier series, and the third one is amplitude phase Fourier series. In this session, you will focus on trigonometric Fourier series. What is trigonometric Fourier series? Here mentioned the Fourier transform, any particular periodic function of the frequency omega can be expressed as the infinite sum of the sine and cosine function that are integral multiple of omega. Okay, this means that this trigonometric Fourier series is a way to break down any periodic signal or function into a combination of simple wave shape such as the sine and cosine. So imagine you have a signal or the pattern that repeat over time and time, like the sound wave. So this trigonometric Fourier series tells us that we can rebuild this repeating signal using the sine and cosine wave, okay, with different frequency. So this sine and cosine wave are smooth or the regular curve that able to goes up and down by adding together the sine and cosine with different frequency and different amplitudes. So you can recreate this shape of almost any repeating signal. So this breakdown is actually is like finding the ingredients of the signal by knowing the individual sine and cosine wave that makes up a complex signal. Then after that, we can process it, analyze it, and understand it better. For real signal xt, we have the negative coefficients. X negative n equal to 1 over t integration of xt multiplied with exponent power of j n omega t dt. So this x negative n also equivalent to xn conjugate. This means that for real signal, the coefficient value for this positive and negative coefficient are conjugate. Okay, conjugates means they mirror image in terms of magnitude but might differ in phase angle. So besides, this is even symmetric in magnitude. So the magnitude of these coefficients is the same but for both positive and negative frequency. So xn equal to x negative n. Means modulus xn equal to modulus x negative n. However, this is odd symmetry in phase. So this means that if the angle for the positive frequency is theta n, then the angle for the negative frequency is the opposite, negative theta, negative n. All right. For mu xt, we have negative coefficient. X negative t equal to 1 over t integration of xt multiplied with exponent power of j n omega naught t dt. So this x negative n also equivalent to xn conjugate. This means that for real signal xt, the positive and negative coefficients are conjugate to each other. Conjugate means they mirror each other in terms of magnitude but might differ in phase angle. Besides, it is even symmetric in magnitude. The magnitude of this coefficient is the same for both positive and negative frequency. So the modulus xn equal to modulus x negative n. However, it is a odd symmetry in phase. So this means that it is the angle for the positive frequency, okay, theta n. Then the angle for the negative frequency is the opposite, okay, negative theta, negative n. From previous slide, we know that the x negative n equal to conjugate of xn. So let's say if xn equal to an minus j bn over 2, then x negative n equal to am plus j bn over 2. So conjugate means if xn is negative, then x negative n should be positive. There's a conjugate different. Alright, normally we will find for the n equal to 0, a not equal to 1 over t integration of xt dt. So this is the formula that you need to remember. Okay, in order to find the trigonometric Fourier series, first of all, we will find for the n equal to 0, then you'll find the a0 value, which is you will use this formula later on. Next, we will find the trigonometric form of the Fourier series. The formula is xt equal to a0. So this a0 is from the previous slide. So this a0 component also the so-called DC component. Okay, so a0 plus with the summation n equal to 1 to infinity, an cos n omega naught t plus bn sin n omega naught t. And this component we say as an AC component. A0, an, and bn are the Fourier coefficients of the trigonometric Fourier series. So you have the formula of a0. This is the formula that I told you just now. And an is 2 over t integration of xt multiplied with cos n omega naught t dt. Okay, n is referred to 1, 2, 3, 4, 5, 6, 7, and until the n. And then omega is 2 pi over t. Okay, t is the period of waveform. And then we find for the bn. Bn is 2 over t integration of xt multiplied with sine n omega naught t dt. So please take note that this cos is for the even term, whereas the sine is the odd terms.
Okay, now let's look at this example. Find the trigonometric Fourier series of the signal xt. So in order to find the trigonometric Fourier series, first of all, you need to find the formula a0. A0 equal to 1 over t0 integration of negative tau over 2 to tau over 2. And then signal xt multiply with dt. So you can substitute the value of xt in this equation. The xt amplitude is 1. So 1 over t0 integration negative tau over 2 to tau over 2. Xt is 1 dt. Then you can integrate the 1, then you can get t. Okay, you can get t. So after that, you can substitute the t with tau over 2 and negative tau over 2. So after substitute, you get 2 tau over 2. So you get, after that, you get tau over t0. Then after that, you can find the an. The formula of an is 2 over t0 integration. Again, the signal is from negative tau over 2 to tau over 2. Then xt, so for the cos, for the an is the multiply with cos 2 pi nt over t0 dt. So when you integrate the cos, you will get sine. Okay, so you will get sine. You substitute the value of xt with 1, then this cos is remain. Okay, so integrate cos, you get sine. Okay, so if you, let's say here is integrate cos at, you will get sine at over a. Okay, the a here is 2 pi n over t0. Okay, so you need to multiply with t0 over 2 pi n, and then you integrate cos, you get sine. So it's from negative tau over 2 to tau over 2. So the t0 you can simplify, this one also can simplify, then you left 1 over pi n. So you substitute the value of t. So you get sine 2 pi n over t0. The value is tau over 2 minus with sine negative 2 pi n over t0. Okay, tau over 2. Alright, so this one you can simplify also, and this one also. So at the end you get 1 over pi n sine pi n tau over t naught plus, okay, negative and negative, you can plus sine pi n tau over t naught. So now you have 2 sine pi n tau over t naught. So you bring out the 2, you have 2 over pi n sine pi n tau over t naught. Okay, so finish the an, then next you can find the bn. Bn formula is 2 over t naught integration from negative tau over 2 to tau over 2 xt sine 2 pi nt over t naught dt. Okay, so again you substitute the xt with 1. So integrate sine, what do you get? So integrate sine at dt, you will get negative cos at over a. Okay, so 2 over t naught. So integrate sine, you get negative cos 2 pi nt over t naught divided by, okay, divided by 2 pi n over t naught. So you divide, you get positive and multiply, so t naught over 2 pi n. Okay, and the limit is still from negative tau over 2 to tau over 2. Then you can simplify this one, then you get 1 over pi n negative cos 2 pi n t naught, you substitute the value of tau over 2, then minus cos 2 pi n over t naught, now substitute with negative tau over 2. So what do you get? 1 over pi n negative cos pi n tau over t naught. Okay, so negative you get positive cos 2 pi cos pi n tau over t naught. This is negative. So negative positive is still remain, means that this one, if you bring out this one, you can be negative. I mean, this negative is the same value. Even you bring out also the same, because cos negative pi n tau over t naught equivalent to cos pi n tau over t naught. So negative cos plus positive cos, you will get 0. So bn, the answer is 0. So now we can write down the final answer of xt equal to a naught plus summation of n equal to 1 to infinity an cos 2 pi n over t naught t plus bn sine 2 pi n over t naught. Okay, so you substitute the value of a naught, which is tau over t naught, plus an. Your an value is this one, 2 over pi n. Okay, so I write down the summation n from 1 to infinity 2 over pi n sine n pi t divided by t naught, then multiply with the cos 2 pi n t over t naught. Okay, so this is an plus with bn. Your bn value is 0, so just leave it at 0. So this is your final answer of this question for to find the exponential trigonometry Fourier series. Thank you.
If compared between exponential and trigonometric Fourier series, exponential Fourier series provide a much simpler or easier solution. Okay, then note that the value of a naught, okay, in the trigonometry and x 0 in exponential actually is equal at the same. So when the signal is the even symmetric signal, just like the previous example, it can be seen that the Bn is 0. So this is part of the properties. All right.
Now let's look at the example again. Look at this example. This xt is 1 t naught is 0 to 2 pi. Okay, and then the amplitude here is 1. Then from 0 to pi, you have the value of t over pi. And then from pi to 2 pi, the value is 0. So you need to find the trigonometric Fourier series. So first of all, again, you need to find the a naught. We follow the formula 1 over t naught, okay, is from, what is the limit here? Okay, so this, if this is t naught, so we know that the value is 0 to pi only. Okay, so 0 to pi. And then the value, okay, we write the formulas first. Okay, all right. And then we substitute the value of t naught. The t naught is 1 t naught is 2 pi. And then the value from 0 to pi is t over pi. We follow this one. Okay, given the xt is pi over tau. T over pi. And then if you want to write again, if you don't want to write, also can. So this is pi to 2 pi, the value is 0. If you don't write, also can. Okay, then you can integrate. So you can take out the pi, 1 over pi, and then you integrate the t. You get t squared over 2. Limit is from 0 to pi. So here you take out the over 2. So you get 1 over, okay, 2 times 2 you get 4, pi times pi you get pi squared. Then this one is substitute the value of t with pi and 0, so you get pi squared minus 0. And here you can cancel out, there's 1 over 4. Next, we can find the value of an. An is 2 over t naught. Okay, integration of xt cos n omega naught t dt. Okay, before that, what is omega naught value? We know that the t, okay, the t naught is 2 pi. So omega is 2 pi over t. So you get 2 pi over t naught is 2 pi. So you get omega is 1. Right? So t naught here is again is 2 pi. Okay, and then 0 to pi, we have the value of t over pi. Multiply with cos n omega naught is 1, so t dt. So cancel out, the left 1 over pi, and then this pi we also can take it out, so it's 1 over pi again. Then multiply with 0 to pi cos t multiply with cos n t dt. Okay, if you look at here, it's integration of cos t multiply with cos n t. So you cannot straight away do the normal integration. So you need to apply integration by parts. For this one only, okay, for this one. So do you still remember the formula? The formula is integration of uv prime dt equal to uv minus integration u prime v dt. So this is the formula we are going to use to substitute the value. Okay, so if you look at here, you have the t, you have the t cos nt. So t is u. This one is v prime. Okay, so you know that u equal to t, then u prime equal to 1, then v prime equal to cos nt, then v prime v equal to sine nt over n. Okay, so we substitute in. Okay, so integration of t cos nt dt equal to uv minus u prime v dt. So u here is t, u prime v is sine nt over n, minus with integration of u prime is 1, v is sine nt over n dt. So you simplify this one, still refer to t over n sine nt minus, so this you take out this 1 over n, and then you integrate integrate sine, you get negative, integrate sine, you get negative cos over n. So you have negative cos nt over n. And here you get t over n sine nt, negative negative, you get positive 1 over n squared cos nt. So now you can substitute back. Okay, from here you start again. So an equal to 1 over pi, then 1 over pi again, then you substitute with this value. So t over n sine nt plus 1 over n squared cos nt, the limit is 0 to pi only. So here we summarize is 1 over pi square. Okay, you substitute the t, the small t here, and the t here, and the t here with pi. So pi over n sine n pi plus 1 over n square cos n pi. Okay, then you minus with the t substitute with 0, minus, okay, t substitute with 0, so everything will get 0. So minus, minus and plus, you get minus 1 over n square cos n 0. Then you will get 1 over pi square. So this one you will get 0. So this one remain, this one 0, this one also cos n0 is 1. So at the end you will get 1 over n square cos n pi minus 1 over n square. So if you simplify, you can get 1 over n pi square cos n pi minus thing with 1. So now the n, you can test for the cos n pi here. The cos n pi can be from, you can test from n to 4, from 1 to 4. So you can test cos n pi. Okay. Okay, so if cos 1 pi, you will get negative 1. If cos 2 pi, you will get 1. Similar to cos 3 pi, you will get negative 1. And cos 4 pi, you will get 1. So if this is the case, okay, you know that the n for n equal to even and n equal to odd is different value. So now we can substitute in. Okay, substitute in here. So 1 over n pi. If let's say let's say cos n pi equal to odd. Okay, odd, you will get -1. If -1 minus 1, you get -2. So the answer is 2 over -2 over n pi square. So this is for n equal to odd. Okay, again, when n equal to even, let's say n equal to 1, n equal to 2, you have cos n pi equal to 1. So 1 minus 1, you get 0. So the answer is 0 when n equal to even. So this is the an value. Okay, we finished the an value. Next, we can find for the bn. So bn, the formula is 2 over t naught xt sine n omega naught t dt. So t naught is 2 pi, and then xt is t over pi, the value from 0 to pi, and then multiply with sine n t dt. So this one can cancel. You bring out the 1 over pi. Then you integrate t multiply with sine n t dt. Okay, again, this part we cannot integrate directly. We need to apply integration by parts again. Okay, so here we assume that this one is u, this one is v prime. So u equal to t, u prime equal to 1, then v prime equal to sine nt, then v equal to negative cos nt divided by n. So if you want to, in the question is v prime equal to sine nt. So if you want to get v, you have to integrate. And then you can apply the formula. So uv prime equal to uv minus integration u prime v dt. So we can substitute this value. U is t, v is negative cos nt over n. Minus with integration of u prime is 1, v is negative cos nt over n. Okay. So we can write down like this, negative t over n cos nt. So negative, you can get positive, and then you integrate cos. Okay, integrate cos nt, you will get sine nt over n. So initially you already have 1n, and then this one is sine nt over n. Okay, then you simplify. So 1 over n times n is n squared sine nt. So you can simplify. Okay, so after this, you back to the question. Okay, you back to the question is from here. So bn equal to 1 over pi square, and then you substitute this value. Negative pi t over n cos nt plus 1 over n square sine nt, and then the limit is 0 to pi. Okay, then it's 1 over pi square. Here you substitute the t, or this t, you substitute with pi n 0. So negative pi over n cos n pi plus 1 over n squared sine n pi. Okay, minus with, okay, the t is 0, you will minus 0. Okay, so minus again with 1 over n square sine n 0. Okay, so sine n pi, we know that this one will contribute to 0, this one also 0, so you left 1 over pi square 1 negative pi over n cos n pi, the rest is 0. So again, you can test for the cos n pi. So just now you already test for n equal to odd, the cos n pi, you will get -1, and then for n equal to even, the cos n pi is equal to 1. So you can substitute in here. So after you substitute, let's say for n equal to odd, okay, n equal to odd, what do you get? For n equal to odd, you get -1. Okay, so -1 multiply with negative pi over n, so you get positive. Okay, positive. Then you get so from here you can simplify also. So you can simplify, so you can get -1 over n pi cos n pi. Okay, then it's easy for you. Okay, you substitute in when n equal to 1. Okay, n equal to 1 is the odd, so you get cos n pi equal to -1. So -1 multiply with -1 over n pi, you get +1 over n pi when n equal to odd. And then when n equal to even, your cos n pi is equal to 1. Okay, equal to 1, so you have the negative value. Alright, and then lastly, you can write down the final answer of xt equal to a naught. So a naught in this case, what is the a naught value? Okay, a naught is 1 over 4. And then this is your an. Then lastly, this is your bn. So you have to combine all the value. So 1 over 4, okay, plus with the an. So an just now is, what is the value? -2 over n pi when n equal to odd only. Even is 0. So you can write in this way, minus, okay, n equal to odd only to infinity. The value is 2 over n pi square, okay, cos n t. And then for the bn, so it's negative. Okay, so in this case, we also can change. Okay, we also can change this one. We also, instead of you write in this way, you also can write another way. Is this one you can change to -1 power of n over n pi. Okay, so you can change to here -1 power of n over n pi sine, okay, you multiply with sine nt. So this sine nt is from the formula. So this one is from n equal to 1 to infinity. If you don't want to write when n equal to odd, so if this one actually is a combination when n equal to n pi, this is for the odd to infinity. Okay, then sine n pi. Okay, if you want to write the even and odd, you can write in this way. Okay, all right, so that's all for this question.